All right, let's get into it. You know, when you're deep in the weeds coding an MQL5 program, you're focused on logic, functions, all that good stuff. But what if I told you there's a secret, built-in dashboard waiting for you, a control panel that gives you instant feedback and command over your program? We're talking about predefined variables, and today, we're not going to look at them as some boring reference list. No, we're going to see them for what they are, the essential instruments you need to pilot your code like a pro.
Just think about it for a second. Your EA is live, it's on a chart, it's crunching numbers, maybe it's even managing real money. But do you really know what's going on under the hood? Do you know its current status or why it might have suddenly stopped working? If you don't, you're pretty much flying blind, just hoping for the best. And that's exactly where this dashboard comes into play. MQL5 gives you this set of super powerful, always-on variables that work just like the instrument panel in a cockpit. They give you all the critical info you need about your program's environment, its internal health, and they even let you fine-tune the controls. Honestly, mastering these is what separates a passenger from a true pilot.
So first things first, before you can do anything, you need situational awareness, right? A pilot has to know their location, the condition of their aircraft, and your program is no different. So let's take a look at the gauges that tell your program exactly what's going on around it.
The most basic fundamental gauge on our dashboard has to be symbol. It's just a simple string, but think of it as your program's GPS. It tells you instantly if you're on EURUSD, BTC/USD, or something else entirely. This little variable is the cornerstone of context for all your trading logic. With it, you always know where you are.
Next up, we've got a really important system check. Is X 64? This is a simple true or false value, a boolean, that tells you if you're operating in a 32-bit or a 64-bit environment. Now, you might be thinking, okay, that's a bit technical, why do I care? Well, for more advanced stuff, like working with external DLL files, knowing your architecture is absolutely crucial.
And here's a perfect practical example of why that matters. Say you want to import a function from Windows, like a simple message box. Well, the system actually expects a different function signature depending on whether it's a 32 or 64-bit environment. By using the _x64 variable, your code can check the environment first and then call the correct version. This tiny check is the key to preventing crashes and making sure your program can run pretty much anywhere.
All right, so we know where we are. Now it's time to check the program's internal health. This part of our dashboard is all about the warning lights, the status indicators that tell us if everything's running smoothly or if we need to take some kind of immediate action.
So, meet stop flag. I want you to think of this as your program's big red emergency brake. It's a Boolean variable, and during normal operation, it just sits there set to false. But the second the user tries to remove your program or the terminal starts to shut down, this flag flips to true. This is your one and only signal to stop whatever you're doing and stop it safely.
And this shows that process perfectly. See, a professional MQL5 program doesn't just run until it hits a wall. No, it's constantly checking _stop flag inside its main loops. As soon as that flag turns true, it stops what it's doing, it saves any important data, closes files, deletes objects, and then exits gracefully. This is how you prevent corrupted data and avoid those half-finished trades.
But what if your program stops and you didn't expect it to? How do you figure out why it shut down? That's where _uninit reason comes in. This is your program's black box recorder. It's an integer that holds a very specific code that tells you the exact reason for the shutdown. For debugging, this thing is an incredibly powerful tool.
And here are just a few of those super important codes straight from the MQL5 reference. Did your EA get removed because the user changed the symbol on the chart? Well, that's reason chart change. Or maybe they just flat out closed the terminal. That's reason close. By checking this code in your onDinit function, you can log the exact cause of the shutdown, which makes tracking down bugs so much easier later on.
Okay, so we can read the environment and we can check our own vitals. Now it's time to actually take the controls. This last section of our dashboard is all about the variables and constants that let us actively fine-tune the behavior of our indicators and strategies with some real precision. I'm willing to bet that anyone who's ever used a moving average or really any standard indicator has seen this exact dialog box. You've got that Apply To field, right? It lets you choose if you want your calculation to be based on the close price, the open, the high, a typical price, whatever. But how do you control that from inside your code? Well, the answer is to use these predefined constants. The enum applied price set gives your code direct access to those exact same settings.
So when you're creating a custom indicator or calling one with iCustom, you can just pass in price close or price typical to programmatically control exactly which price data gets used. This gives your algorithm the same fine-grained control as the user interface.
Now here's a control that is absolutely vital for any kind of scientific testing. Underscore random seed. See, every time you ask MQL5 for a random number, it uses this internal generator. Underscore random seed holds the current state, or seed, of that generator. But here's the cool part, you can also set it yourself. And why is that such a big deal? One word, reproducibility. If your strategy has any kind of random element, running the same backtest twice might give you two totally different results. But by setting underscore random seed to a specific value at the start of your test, you guarantee that the sequence of random numbers will be the exact same every single time. This is what makes your research valid and your results verifiable. It's a cornerstone of good testing.
Okay, let's bring it all home. We've looked at the gauges, the warning lights, and the control inputs. By really understanding these predefined variables, you're not just writing lines of code anymore. You're actually taking command of your program. You're making that jump from being a coder to being a pilot.
So, quick recap of our dashboard. We've got our environment gauges, like underscores and isX64, to give us that crucial situational awareness. We have our vital warning lights, like underscore stop flag and uninit reason, to ensure safety and help us with diagnostics. And we have our fine-tuning controls, like the applied price constants and underscore random seed, to give us precision. These aren't just random variables, they are your instruments for total control.
The variables we've covered today are definitely some of the most important, but believe me, they're just the beginning. The MQL5 language is packed with these built-in instruments, just waiting for you to use them. So the real question I have for you is this. Now that you know how to read the main dashboard, what other controls are you going to discover to make your trading programs even more robust, more intelligent, and more powerful?